Okay, so we have a linear transformation from Rn to Rm, and this is a linearly dependent subset of Rn, and we would like to examine if this is a linearly dependent subset of Rm. Okay, the the space that contains the uh, image of T. Okay, all right. Now, one of the criteria to check whether this is a linearly dependent subset of Rm or not is that if we can find these coefficients like or scalars, say alpha 1, alpha 2, okay, and all sorry for my slow writing here, okay, and then alpha 3 and alpha 4, which are not all zeros, okay, not all zeros, such that what happens is that the linear combination of these four vectors by using these coefficients is a zero vector. That is, we should be able to find these scalars alpha 1, alpha 2, alpha 3, and alpha 4, okay, such that this linear combination is a zero vector in Rm. Okay, all right. So let's just write that in Rm. Okay, so this is what we have to check. If this check is satisfied, then these are linearly dependent. If not, then we have to check something else, whether that works or not. So notice this is a linear transformation. So what has to happen is that this will be the image of who? Alpha T of alpha 1 V1. Okay, let me write it down. Give me a second. So we have to have this that, I mean, you can see that the image of this vector is this vector because T is a linear transformation. So we have that this vector is 0. Now, this gives us a good hint to see whether we can find these or not. So let's begin with this. That is, notice this, we are given that this is a linearly dependent subset of Rn. So what will happen is that we can find these scalars which are not all zeros, such that what happens is that this linear combination is 0. Okay, and of course we didn't have to use the same symbols alpha 1, alpha 2, alpha 3, alpha 4, strictly speaking, but anyways, let's just go with this right now. Now if we apply the transformation or linear transformation T on it, okay, so what will happen is that this would be T of 0, and T of 0, the image of 0 under a linear transformation is still a 0. Now what happens is this entire linear combination is this vector. So we have this, right? And then T0 is 0. So what have we been able to do is that we have shown that we can find alpha 1, alpha 2, alpha 3, alpha 4, which are not all zeros, such that this linear combination is 0, and that will give us what? That will give us what we wanted to check, that this set is uh, linearly dependent subset of Rm. And as I said, we just kind of went more like in an exploratory manner. So when we were mentioning these alpha 1, alpha 2, alpha 3, alpha 4, they didn't necessarily have to be the same symbols. Okay.